Gujarati Education. Let's begin with today's topic. I hope you all are doing great. शुरू करते हैं आज का टॉपिक चलिए.
Hello everyone. So I hope you are doing great. We are going to cover one important concept today, and the concept that we are going to talk is the application of. We are going to learn the application of formula sum of infinite terms of a GP. GP is geometric progression. You must have studied geometric progression. So we are going to learn here the formula is sum of infinite terms is given as a upon 1 minus r, where a equal to first term and r is the common ratio, right? So we are going to apply this formula and solve a very crispy interesting question which is very important for the exams like IPM, IIM Indore, CAT, GMAT, all these exams, right? Let's find out. The question is, here the question goes, find the value of 4 upon 3 multiplied by 10 upon 9 multiplied by 82 upon 81 multiplied by 6562 divided by 6561 multiplied by dot, right? So this is the pattern. This is an infinite series and we need to find the sum of this infinite series. Now here, it's not a direct GP, right, geometric progression, the series that is given, the expression that is given. So how we are going to apply this formula, right? If you observe carefully, you see that you can write 4 upon 3 as 1 plus 1 upon 3. You can write 10 upon 9 as 1 plus 1 upon 9. That is nothing but 1 upon 3 ka square. Right. 9 can be written as 3 square. Similarly, you can write that 1 upon, right. You see when you add, this will become 82 upon 81. Right. You can write as 1 upon 1 plus 1 upon 6561. Right. If you see carefully, you will understand that these are why we are applying. What is the first thing that you should notice about this question? You should notice power of 3. 3 ki power 1, 3 power 2, then 3 ki power 4, right, and 3 ki power 8, and so on. So power 1, 2, 4, 8, these are in GP. If you look at the denominators of all the numbers, the denominators form a GP clearly. 9 divided by 3, 3, right? 81 divided by 9. I mean, if you write it in this format, 3 ki power 1, 3 ki power 2, they were 4, right? 3 ki power 8, and if you divide R, if you find out R, you'll be finding always 3, right? 3 ka power, not forming R because of the first term. I mean, the difference of difference. If you take the ratio of this, take the ratio of this, and then if you take the ratio of all this, then they will form a common ratio, not now. But still, if you observe denominator carefully, it is 3 ka power. And that is enough to give you a clue that whether we should think it this way. And numerator is slightly just one more than the denominator. So whenever you see, you can write the numbers in this format. Just assume 1 upon 3 as x, because then we won't be able to write. We can write 1 upon 9 as 1 upon 3 ka whole square. So that means we can say x square. Similarly, 1 upon 81 could be written as 1 upon 3 whole ki power 4. So we can say x ki power 4. I hope you are understanding. Right. So this way we can write. So now if I'm going to write this, we are getting the expression 1 plus x, 1 plus uh, x square, right? Because 1 by 3 is x. 1 plus x to the power 4, 1 plus x to the power 8, and so on, right? I hope this is clear to you, right? Now, if you multiply, you will be getting all the terms present here, right? Like if you multiply, you will be getting 1 plus x square plus x cube also, because x square into x will give you x cube, right? Then x to the power 4 also, x4 plus into 1, right? You will be getting x to the power 5 and so on. If you observe this expression 1 plus x square, right, and so on, you see that this is forming a GP in infinite series. And here there is an important thing that I need to tell you, that this is applicable only when r lies between 0 to 1, means r is a fraction. So if you see our r is x upon 1, that is x, which is nothing but 1 upon 3. So that is lying between 0 to 1, right? So we can apply the formula. I hope this is clear to you. Why we can apply this formula? Because now we can clearly observe that this is a GP series till infinity, and where our r is 1 upon 3, satisfying the condition. This formula is valid only when r lies between 0 to 1, that is a fraction. 0 to 1 means fraction, lies between, not equal to. So here you know the formula 1 upon 1 minus r, that we know x. So 1 upon 1 minus r is 1 upon 3, that when you solve, you will be getting 1 upon 2 upon 3, and hence 3 upon 2 is your answer. I hope this is clear. Right, I'll explain once again quickly so that you can understand. आप वैसे भी एग्जाम में अगर देखोगे इस पूरे एक्सप्रेशन को तो आपको एक क्लू मिल ही जाएगा। दिस इज स्लाइटली 1 से ज्यादा, दिस इज 1 से ज्यादा, सब 1 into something. You keep multiplying 1 into infinite numbers, you will never reach 2. It will be between 1 and 2 only answer. This option is 1.5. But what if there are more than one options present, right? Then in that case, as I said, that numerator is just one more than, so you can write the expressions in this format, which is a standard format that you need to remember for future questions. And once we wrote this, we also observed that the denominator are powers of 3. So we assume that 1 upon 3 is x, whatever variable you can assign, and hence the expression can be rewritten as 1 plus x square, because this becomes 1 upon 9 is 1 upon 3 ka whole square, that is x ka square, and so on. Now after multiplying, if you want to observe this, for students who are not very clear with multiply, they can multiply two terms, then those two terms to the third term separately, then those three terms to the fourth, and you will observe that you will be getting all these terms. This is x to the power 0, x to the power 1, 2, 3, 4, 5, dot, 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 till infinity. So now, since x is 1 by 3, lying between 0 to 1, we can apply the formula for sum of infinite terms of a GP, that is a upon 1 minus r. We have applied that and calculated the value as 3 upon 2. I hope this is clear. We'll meet in the next session with another very important concept and question.